Action.
The next speaker is Jonathan Gemmell. Jonathan holds a BA in Classics, an MS in Computer Science, and a PhD in Computer Science, and he's now here at DePaul University. He will be giving a talk on the title of Learn by Doing, Predicting West Nile Virus in Chicago. Thank you very much.
All right. Hello, everybody. How are you all? Very good. All right. I have a couple questions for you. How many of you are interested in Python? All right, good. We're in the right place. Excellent. How many of you are interested in data science? All of us? Very good. I like this answer. Okay. And how many of you are interested in mosquitoes? You get really excited on the topic of in dinner parties, you just bring up mosquitoes just for the chance. All right. So what I want to talk to you today is the intersection of Python, data science, and mosquitoes. All right. So I have this problem. I teach data science here at DePaul. I teach CSE 423, which is regression. I teach CSE 424, which is CCA, PCA, LDA, all the three letters you put together. And one of the problems I run into is that I'll teach something like LDA. Who knows what LDA is? Linear discriminant analysis. My students should be raising their hands. All right? Linear discriminant analysis. So this is like a 3-hour a lecture on a Tuesday night, and we get in there, we talk about matrices and eigenvectors and Fisher's criterion, and it goes on for about 2 hours, and for those who are awake at the end of the lecture, I say, okay, and then if we have LDA, we can build a classifier, and we could take that classifier and use something to predict something like churn, like who in the business, if your business, which of your customers will leave you that month, right? You don't like churn if you're a business person. Or we could predict disease. They have cancer or they don't have cancer. Or we could predict fraud. This person who just used a credit card is a fraudster or they're not a fraudster. And as an educator, this is terrible because this is not what happens in the real world. Who actually is a data scientist here? Okay, so did your boss ever come to you and say, I need an LDA model, stat, all right? What do you want to model? I don't care, I just need an LDA model, right? So that's not what happens, right? It's not the case where you have the solution and then you figure out what problem you want to apply it to. More often, this is what you have. You have a problem, you're trying to predict disease, and you're trying to figure out what's the best way to predict disease. So maybe you build a SVM, maybe you build LDA, maybe you do logistic regression. And this is much more akin to what my students might see in the real world, so I try to give them this type of problem whenever I can. Okay. To that end, I've often encouraged them to use Kaggle. Who has used it? Who has actually seen Kaggle before? You compete in it? I might have some of your code up here. That would be embarrassing if I saw that, right? So Kaggle is a platform for companies and researchers to post their data, and they say, I want to predict this problem, model this problem, and students or researchers or whoever can go online, they can write code, and they can compete to see who can build the best model, to make a prediction or to build the best a classifier. So a couple they have a training example there, trying to predict who will survive the Titanic. So they have variables like male, female, what class they have, how old they were, and it's just a training example. Facebook has a contest on there right now. If you win that contest, you get a job interview. Another one I think is really interesting. They have several thousand images of the back of eyeballs, right? Those little cameras you use when you go see the eye doctor. And you have to determine which of those pictures do the patients have diabetic retinopathy. What's that? Retinopathy. Very good. Are you an optometrist? Perfect. And that's where this data set comes from. Excellent. Yeah. And another data set is trying to predict the usage of bikes in a bike share program, like the Divvy bike share problem here in Chicago. And so the notion here is that, well, if you were worked at Divvy, you could pay one data scientist to try and build the best model you can, or you could post your data set on Kaggle, and you can get thousands of people to work on your data set. So this has some good and bad for us in particular. The good is that we get data. For those of you who work in academia, data is a precious thing, right? Hard to get your hands on. It gives us an opportunity to learn from our peers, and we have a group of people working on the same problem, so we can talk about our ideas, we can get feedback on our own ideas, we can see what other people come up with. The bad is also the data, all right? So as you all know, anybody who's worked with data, whenever you're presented with a problem, you just simply go online and you download the CSV file you need, and then build a model of that CSV file, right? That's how that works? Yeah, my student's shaking her head. No, that's not how that works. That was sarcasm. So one of the biggest problems in data science is trying to get your data built and organized and trying to find the right data to solve the problem you're working on. So Kaggle, my students sort of missed that prospect, but that's the best we can do. Another problem we have with Kaggle data is the definition of success. So when you want to build a good model, you want a model that is accurate, but you also want a model that you can explain. It's very useful when you can go into the boardroom and put up a tree and say, okay, this is why this model is built in this way, so it gives you insights into the data. It doesn't just give you the best recall or precision. We want a model that is fast, okay? And we want a model that is cheap, and I mean cheap in terms of how much CPU time it takes, but also cheap in how much time it takes to get the variables themselves. Might also be cheap in terms of the social impact you place on your customers. If I ask you your age and your zip code, you probably tell me. If I ask you how much money you have in the bank, you're less likely to tell me that. There's a social cost in me trying to get that information. But from the age and your zip code, I pretty much know how much money you have in the bank anyways. So trying to find variables that are inexpensive in some way to collect. So overall, they're good and bad. You have to understand what these are when you're telling your students to go work on a Kaggle contest and explain to them that this is what they have to look forward to. So one of the contests that's going on now is the process of trying to predict the West Nile virus. This is sponsored by the Robert Wood Johnson Foundation and the Chicago Department of Public Health. Winners of this contest will get $40,000. Anybody actually working on this one? Okay, my students should be raising their hand. All right, good. Final submission is just in a couple weeks. So I am using this data set in class. I'm teaching 424 this quarter. I have 4 undergrads, 27 grads in classroom, and 18 graduates online all across the world. And there's a predictive analytics group here, a student-run organization interested in data science, and they have 6 students working on this themselves. Internally, we're running our own contest. I don't have $40,000 to shell out myself, but the winning group who wins the Kaggle contest in our class will get a chocolate cake that I will serve them during the final exam. Right? Yeah. So there's big stakes at hand. Yeah. I might bring something for the losers too, like a fruitcake or something. I haven't decided yet. So the West Nile virus, it's been along for quite a while. It was first identified in 1937 in East Africa, but prior to the 1990s, it wasn't really on anybody's radar. In 1994, there was a case of West Nile virus in Algeria that caught people's attention, and 2 years later in Romania, there were a high number of cases with neuro-invasive disease. The first cases here in the West occurred in 1999 in New York, and since then it's spread all over the US, Canada, and further south. In 2012, just 2 or 3 years ago, West Nile virus killed almost 300 people in the US, most of that being in Texas. And here we have it doesn't look as good on the big screen, but here we have a map of the US, and you can see a lot of the malaria is all over the US, and concentrated more in the south and that center part there. All right, so how is this transmitted? So mosquitoes are the prime vector, but birds are really the host of these things. So what happens, the infected mosquito is eaten by a bird, okay? And then mosquitoes harass the birds, get the disease back, and they pass it back and forth among each other. It's actually it's rarer for a human being to get the virus or livestock or something like this. So the main cycle is between the mosquito and the birds. Of course, human beings, the way we think we should kill all the mosquitoes, I guess another possibility would be to kill all the birds, but I'll leave that to the government to figure out what they should work with. 80% of the time, if you have West Nile virus, you don't even notice it. When you do notice it, it's usually a fever, a headache, fatigue, some sort of, it's a bad weekend, you just don't feel good. Less than 1% of the time, the conditions are more severe. You get swelling in your brain or in the tissues that surround the brain or in the spinal cord. And there is no pill that you can take for West Nile, the virus. So really the way to combat this disease is to stop the spread of it by attacking the mosquito population itself. Funny story, I used to actually have this job. So in my bio, you heard that I had a bachelor's degree in classics, right? Since when I was 22, my skill set was I knew how to read ancient Greek. And you'll be surprised to learn that it's kind of hard to find a job when that's your skill set. So I ended up driving a Jeep around Des Plaines, spraying larvicide oil into the sewer grates, killing these guys. These are mosquito larvae, and they cling to the surface of the water. If you put a little oil on top, they sink to the bottom, and then they drown, right? So if you lived in Des Plaines in the late 90s, you're welcome. wasn't any West Nile virus in Des Plaines in the 90s, and I'll take full credit for that. Right? So this is the data that Kaggle gives us. We have the map of downtown Chicago. We have the data for the weather going back, I think, 6 years. That includes the temperature, the high, the low, the average. We have how much it rained, how humid it was, the wind speed, those sorts of things. We have spray data, where the trucks went around and sprayed for the mosquitoes. And then they have these traps set up all over the city. And for those traps, we have the location where the trap is. We have how many mosquitoes they caught. And we have true or false whether or not West Nile virus was discovered at that trap on that day. Okay? So it's kind of interesting information. So on Kaggle, you can go in to the Kaggle, and they're very good, particularly in this contest, I think, about offering sample code for people to get started. Okay? Now they have sample code in Python, in R, and in Julia, and some more. So there's a lot of people who have just tried something, they've posted it online, and so it's a great place for my students or for you if you're trying to get started with a project to see how other people would approach it. So they have a logistic regression, neural networks, random forests, all of these great things. Okay. For example, this is from the user David Chajewski. Sorry, David, for butchering your name. But this is a histogram showing the distribution of the number of mosquitoes caught in each trap. The ones that scare me is these over here, right? Thousands of mosquitoes in this one trap on this particular day. I don't know what was going on, but I do not want to be in that neck of the woods. This is the city itself, and each one of these points is a trap. This is done in Python as well. And the color of the dot indicates how many mosquitoes were caught in this trap. So up here, you can see there's a darker point right here. The lighter points over here are more interesting. This is by a user called Vasco. He has posted all of his code online to create this plot. And this is a heat map now of the West Nile virus itself. Not the mosquitoes, but where the West Nile virus is. Okay? So up here on the north side is, anybody from around here? All right. Okay, we might want to coordinate so everybody don't get anybody infected. Stay away from birds. So this area here seems to be a hot spot for the mosquitoes themselves. And if you look at a map, it makes somewhat of sense. The river is right here, and you guys know what this area is right here? Yeah, there's a lot. Yeah, there's a lot of forest right there. So that's where the mosquitoes really breed, and then the wind blows them a little further west in this hot spot over here. So all this code is online. You can see him aggregating the data. He's using pandas, NumPy, matplotlib. Scikit-learn is in somewhere in here, I think, also. So even if you don't know Python, right, or even if you know, it's just enough to get started, right, and you want to try something, you can start with this and see where it will take you. This is the same data, but it's across the across 4 years: 2007, 9, 11, and 13. So there's 4 years worth of training data, and it's the odd number years. The testing data is 2012 and 14, I think. It's either 10 and 12 or 12 and 14, but it's the even number years. And you can see there's a different distribution of where the West Nile virus occurs. But up here in this northern floodplain, you see this quite more often. 2007 and 2013 were the hot years for West Nile virus. This was created by user Neil Summers, who took Vasco's work, forked it, and then made his code available to create these plots. Okay. This is by Vasco again. This is the code to create this plot here. This is a time series showing a different line for each of the 4 years for which we have training data. And it's the percentage of traps is the Y variable, percentage of traps that have the West Nile virus. So right around here, week 35, that would be like August, right? That's the worst time to be looking for West Nile virus. And in 2007 and 2013, those were the years where it's more common. They incurred about 25% of the traps in which they were catching the mosquitoes, whereas it was only about 5% for 2009 and 2011. There are, when we think of the mosquitoes, we only think of, mosquitoes, right? But there is actually several different types of mosquitoes, and some do not carry the virus at all. In the data set, there are 8 different breeds, but only 3 of them really carry the virus. These are the 3 that do, and this is for each year, their occurrence of West Nile virus with the traps. So the pippins is much more common, much more likely to carry the virus than the others, for example, in 2007. All right, so now we've done some initial data analysis, right? We've been given a problem, and we're trying to go through the procedure of looking at the data, trying to understand it first before we build our models, okay? So now we need to have some way to build a model, more importantly, to evaluate our model and know how it's working. For this contest, Kaggle uses the area under the rock curve. So if you were to take a diagonal line that just represents a random guess, you want to try and get above that line. And you're thinking, okay, now I have to write code to figure out how well my model's doing. Actually, you don't need to do that because this user, Hendang, has already done that. Most of that is just loading data into it. This is the big part where you just try and figure out, or she just calculates the rock curve. That's this part right down here. This part is just reading the data and parsing it. All right, so now that we don't want to do that, okay, now we have to think about how we're going to build a model. Well, we can get started with that too via Kaggle and all the scripts they have offered. So this here is a script here on how to do a random forest. How many of you have used a random forest before? Random forest is like a decision tree, except you have lots of decision trees. In this case, we have 1,000 of them, and you take the average of all your 1,000 trees and average them in an ensemble. Okay. So this user here spent a lot of time getting his data prepared, and then he used ensemble.randomforest, a classifier, something that you can just use in Python from the start. He's posted all his code online, and he's used it. You can see his rank here He's ranked 499. And if you look at the scores from the other users, I highly suspect that these people just used his code to see how they could do, which is perfectly fine. That's why he posted that online. So if random forest is not doing well, maybe neural networks. So this is Tim Hochberg who's posted this code. Okay. Interesting enough, where this user kind of prepared the data and then threw it into a random forest classifier, this user actually wrote a neural network, right? So he wrote all the code himself. So a student trying to understand this code needs to go in there, and this is actually only part of the code. It would only, this is all that fit. So a student could see how the code works. It's not just a function call now. It's actually see how the nodes are being built. And this user is ranked 216, so doing a little bit better than the decision trees. Or we could do deep neural nets. So this user here has submitted code to do a deep neural nets. Anybody know the difference between neural nets and deep neural nets? That's all it means, right? If it used to be the case that if you had lots of layers, you could overfit, right? And now they've come up with some techniques to avoid that. So you can have neural networks that will work well on your training data without being overfit. And this code is again available. So even if you're brand new to data science, if you know a little bit about it, if you know Python just a little bit, you can get started really fast building models, testing how they work, and submitting them online. And this is, I think, an interesting a paradigm, because it's, in one sense, you're trying to cooperate with all your peers. So, for example, in my class, I have 60 students working on this. I have them each divided up into teams of 6, right? Each team of 6 is trying to get the best score they can, right? So they're cooperating in each group, but they're trying to compete against the other groups, right? So they want to see how well they work. And the same thing is happening here. You have people who are willing to share their information. There's 422 posts right now on the forums for this contest. Okay, people have shared 847 scripts, so there's a lot of information to look at. And you also have this competition built into the system as well. So the top 3 winners there are going to share $40,000. I wouldn't advise you all to quit your job and start doing Kaggle contests as a way to pay the mortgage. I think it's more fun to create a record and say, okay, look, I've been in the top 10% of these last 5 contests. Really sort of show your chops to your peers in the real world. And even if you're all the way at the bottom here, I don't need to pick out Armen Kabashi. 955 out of 955. I'm sure it's a bug. I'll fix it tomorrow. But even if that's where you're at, right, he still learned something through this effort, and I'm sure next time he'll do much better. So this is similar to the slide I showed you before, and this is what I was trying to teach my students when I gave them this problem. We have the problem. The problem is West Nile virus. Can we predict where it's going to occur, when it's going to occur? And the students need to be able to find the solution to this problem, not find a problem that fits their solution. So they're doing things like a PCA and clustering and LDA and logistic regression. They're doing several types of clustering. They're doing k-means, hierarchical agglomerate, DV scan. All of these things. Preparing the data is a big problem for them, and that's something they're working on now. And all of that needs to be pushed into their final work. So learning Python and learning the data science, in part, in my view, is trying to figure out how to take the problem and find solutions that will match to it. Okay. And that was 30 minutes. Perfect.
All right. Questions for the speaker?
So how well do the students do in average in the past?
What's that?
How well did the students do in average in the past?
So, I guess we have trophies for also ran. Uh, uh, it's a good exercise, I think, just to try and figure out how to create a model and then run test data against it. Very often, a random classifier will do better than some of the students. And it's just because they haven't learned how to deal with all the files yet. And that itself is, I think, is an important lesson. And then every once in a while, you'll get a couple students who just, they were like born doing this stuff. And they're up there in the top 10%. We have a couple students who do this actually a lot. And they're consistently in the top 10 or 20%. Yeah. So there's a big distribution. But I think it's, for the students who are in the top tier, I think it's a great challenge for them to be able to do this and to compare themselves with other people who are trying as hard as they are. And even if there's students who aren't doing that well, I think this is the first step they need to struggle with before they can be that student who does well. So I'm doing this right now in CSC 424, which is multivariate analysis. So in this class, they've already taken regression, so they know logistic regression, they know LDA, they know clustering, they know PCA, they know CCA.
Students?
It's an older class. It was in the CS program. It is now part of the core class for the predictive analytics degree.
That are outside of computer science into the class?
Often. There's a lot of career changers who maybe they have a job in marketing or economics or something else, and they're coming back to school to get a master's degree in predictive analytics because they see predictive analytics, I think, is a fantastic field. Where was our previous speaker? Tanya, I think? I'm sorry. You too, right? You're just excited about it, right? There's so much opportunity, right? There's so much challenge. You can make good money. We all like money, right? And you have the opportunity to have really meaningful work that impacts, the business or the community, right? So I see a lot of people coming in who, yeah.
When you teach the course, do you introduce people to like pandas, scikit-learn, numpy, scipy, like the Python stack? I'm just curious how you handle that.
So I teach the class as language agnostic, right? My personal opinion is the language you need to know, you need to learn, is the language that's going to be important 5 years from now. So I try and promote the idea that you need to learn how to learn languages, not necessarily learn a language. Yeah.
You notice students tend to gravitate towards?
I have a lot of tutorials in R, so a lot of them use R, but they're allowed to, some are from the marketing school and they prefer SAS. That's completely fine. I let them use whatever they want. I have a lot of students who use Python. Yep.
So is there some kind of method for choosing whether you want to do a random forest or you want to do a neural net, or is it just guess and check?
I don't like the term guess and check, but I guess that's pretty accurate. So it's funny you say that. You're going to sound like a plant here. In my thesis, I talked a lot about how different data sets will exhibit different performance with different algorithms, right? So you use algorithm A on data set 1 and it works better. You do the same type of thing on data set 2 and algorithm B works better, right? And so trying to find what those algorithms are, I think, is part of the process. And that's why you need to where did it go? That's why you need to get here, right? You need to really define what your problem is and then say, okay, I'm going to try algorithm A, I'm going to try algorithm B, I'm going to compare them and do that over and over again. And that's, I think that's one of the good things and the bad things about Kaggle, because a lot of it becomes just trying to figure out which algorithm is the very, very best, try and get that 0.01%, above everybody else. Or maybe a deep neural net is really nice, but maybe a decision tree that was 2% less, had 2% less recall would be better because it would be explainable. Right? So maybe that's not the case. I can tell you right now what the winning solution is going to be. Right? The winning solution is going to be a hybrid of several of these techniques all wrapped up into one. Right? You agree? Yeah, 'cause that's what it always is. Okay. Another question? Yep.
Ensembling work. Do you just average out the like how I'm having trouble visualizing how you can do that.
So a naive way would be just to take all the outputs from your classifiers, and the output of the classifiers might be a probability that it's class 1 or class 0, and you can just average over across all of the classifiers. A more sophisticated way would to give each one of those classifiers a weight, right? So maybe a classifier that was more accurate, you give a larger vote than to a classifier that was less accurate. Okay. Another way would be do it for each instance, trying to figure out what the best weighting would be. Okay. And there's lots of ways to do this. You can do boosting or linear weighted hybrid, these sorts of things. Yeah, but training those weights is one of the critical things to do. You see a big difference when you do that.
More questions? Okay, let's thank the speaker again. Before we go, we